Conference, your source for JVM knowledge.
Okay, I think most people are probably in the room by now. Can everybody hear me? Are we good with the audio? Yep. Okay. So in this talk, I'm going to do a little Micronaut status update and talk about our what we've achieved in the last 9 months and what our plans are for the future. Do some demos. Kind of follows on from what a lot of Andres was saying about the different frameworks and approaches. This one specifically talking about Micronaut. For those who don't know who I am, my name's Graeme Rocher. I created a couple of frameworks, Grails. I assume most of you have heard of Grails, and Micronaut, of course. I'm an engineer at OCI, Object Computing. This year I was privileged enough to receive a Groundbreaker Award from Oracle for the work that I did on Grails. I'm immensely proud of what we've achieved with Grails over the last 10 years with the framework. It's amazing and continues to be amazing, so it was great to receive that recognition. I used to work for a variety of different companies prior to OCI. And I live in a little village in the north of Spain, in the Basque Country, called Bagara. This is the river that's outside my house, and population, I think, maybe 10,000 people. About as far from anywhere technological as you can imagine, but working from home has its advantages in that sense. So that's hometown for me. That's base station. So on the agenda today, we're going to introduce Micronaut. For those who don't know what it is, we're going to talk about what's new in Micronaut 1.1, the challenges facing Java, some of which Andres alluded to with different languages like Go, offering fast solutions, how Micronaut is tackling those problems head on, and we'll do a bunch of demos. So first of all, let's get out the way what Micronaut actually is, because the branding obviously is very much microservice focused, but Micronaut is essentially a complete application framework for any type of application. It just so happens to be that it works really well in the microservice and serverless space. But you can build any kind of app. Anything with a static void main method to start up is a candidate for use within Micronaut. It is a complete new foundation for doing things like dependency injection, aspect-oriented programming, configuration management, bean introspection, and everything that you come to expect from a traditional framework such as Spring or Jakarta EE and so forth. So like I said, with Micronaut, it's really use what you want and how you want to do it. You can do it pretty much any of these things with Micronaut. You can build microservices, obviously, hence the name. You can build serverless functions that deploy into AWS Lambda or any kind of FAS system. You can write message-driven applications that don't have a UI or any HTTP endpoint that are just consuming Kafka or RabbitMQ messages. You can write CLI, command line applications. The fast startup time and so on is really beneficial for CLI applications. You can even write Android applications, and you can use Micronaut in Android, and the dependency injection part works, and we have more plans to make that experience on Android even better. So pretty much anything that has static void main is fair game for Micronaut. So what is Micronaut really? If you think about it, then it's really a application framework for the future, for the next 10 years. And we made some design choices when building Micronaut that we believe make it really appropriate for the next 10 years of application development with Java. So in Micronaut, there's no reflection at the framework level. There's zero reflection anywhere, from creating your objects to setting properties to invoking your methods in your code. There's never any reflective logic used. We don't use any runtime proxies. There's no runtime proxying, runtime creation of proxies. We have compilation time proxying, but that's computed at compilation time and completely static. There's 0, and in Micronaut 1.1, which is going to be released soon, there's absolutely no dynamic class loading. So everything is statically loaded, which benefits startup time, optimization, and so forth. And it features APIs that allow you to do ahead of time compilation. So there are APIs that you can plug into, which, for example, some examples of this are Micronaut computes your Swagger OpenAPI documentation at compilation time. And that uses that API so that we don't have an overhead of having to parse all your closes at runtime just to generate at runtime your Swagger information. We generate that information at compilation time and save a whole bunch of memory at runtime. Yeah? And the reason these APIs are important is because they work whatever language you choose. So we have a generic API that works whether you use Groovy, whether you use Java, whether you use Kotlin, and it works. And yes, it also lets you build microservices. So why Micronaut and why now? There are challenges to using Java in serverless and microservice scenarios. And many of those challenges are, a lot of people will point to those being problems with the language. Yeah? So you see many cases, and this happened at the AWS event with Tim Bray was speaking, where he was talking specifically about Spring and Java. It's almost like Spring and Java have become like linked so that they're almost one and the same thing. And people relate those two experiences to, but really at the language level, there's nothing really preventing Java from being as fast as these other languages. It's more about the existing tools and frameworks. And the existing tools and frameworks out there for Java are not optimized for cold starts and low memory. They were built at a time when we were all deploying monoliths where everything was in one big JVM. There was no containers. So the reality is that, yes, if you use the frameworks that are most popular out there, the Springs, the Jakartis, whatever, then you're going to see the fact that Go and Node and these things are a lot better in terms of memory consumption and so forth. So the whole Java space is changing and adapting, and Micronaut is really the driver of that. And one of the reasons for this is because any framework that is based on reflection is going to become fat really quickly. It's going to become heavy. If you want to know the technical reason for this, in Java, reflective metadata is stored using soft references. So when you get a class file from an object and its methods and so forth, the JVM is using soft references to hold on to references to those class files and those declared methods and so forth. So what that effectively means is that all that memory is retained for all the reflective metadata, and it's not released until your application is low on memory. That's how soft references work, right? So reflection causes an increase in memory consumption and a decrease in overall runtime performance. But it's kind of, reflection and annotations are the basis of every framework out there that has been built in the last 10 years, apart from Micronaut, and recently Quarkus has tried to do similar things in this area. And really, this is not really a microservice-specific problem. I often ask people, it's like, why should we not be more efficient? Regardless of whether you build microservices with Micronaut or you build monoliths, is there any reason why we shouldn't just be more efficient? There's no downside to being more efficient. So what we're trying to break with Micronaut is this correlation in traditional Java applications between the number of lines of code and the startup time and memory consumption that are very closely linked with traditional applications. And we're trying to do that by using ahead of time compilation to pre-compute all of this data at compilation time that's needed to execute your application. So it was a year ago at last year's Greach here at this conference that we announced Micronaut for the first time. We didn't make it public. We made Micronaut public. We open sourced Micronaut on the 28th of May, I think it was, around about then. But we announced plans to make it open source at this conference last year. And ever since then, it's caused an absolute revolution in the server-side Java space. We have companies, major, huge companies like Red Hat and Pivotal, pretty much scrambling to make their frameworks better to compete with what we've achieved with Micronaut in the last 9 months. Red Hat have come out with Quarkus, which is very much based on the same kind of concepts. Pivotal are trying to get Boot to consume less memory and start up faster. We'll see about that. And it's essentially Micronaut is changing the face of server-side Java. Yeah, it's completely changing industry strategy, and that's just in 9 months. And so it's had a massive impact, and it's the technology on server-side Java that everybody's talking about right now. So, like I said, Java's problems are greatly exaggerated. Java has been dead forever. If I've heard how many times people have said Java was dead, Java was dead when Rails came out. Java was dead when Node came out. Java was, Java's been dead for like 20 years if you if you listen to people. But it's not a reality. Java can be fast. If Java wasn't fast, Google wouldn't have chosen it for Android, right? Because on Android, you need applications to consume a little amount of memory on a device. You need them to load fast. On server-side Java, we actually have a lot to learn from the Android community, which are, those guys are in the other room over there, because they've been doing ahead-of-time compilation for years on Android, and eliminating a reflection with tools like Dagger and so forth. It's been happening for years, and the server-side part of Java has just kind of ignored it. But really, we have a lot to learn. And it's all about these existing tools. If you use an existing tool that is based around reflection, runtime creation of proxies, and runtime bytecode generation with either Buddy or CGLib, your memory consumption is going to suck. There's no doubt about it. You cannot use these things and get low memory consumption. It's not possible. And then there's prior to when we started building Micronaut, GraalVM didn't exist. We had no idea that this technology was coming, and it's a very interesting technology that lets you essentially convert your Java application into a native application, which has some obvious downsides, like the compile times are slow. Suddenly you've lost write once, run anywhere. There's various problems that it introduces. However, it does result in amazing 20 millisecond startup time and memory consumption of 18 megabyte, which for a Micronaut app is for certain use cases is pretty amazing. I think that the technology has massive potential. It still very much feels very like alpha technology, beta technology, and it's still evolving, but it's exciting. So GraalVM is something to keep an eye on, and Micronaut works really well with GraalVM, and it just kind of worked really well out of the gate because we decided to make those decisions early on with Micronaut to eliminate reflection, eliminate proxies and so forth. So yeah, GraalVM is a really interesting project. Micronaut optimizes for Graal, and in Micronaut 1.1 we've done a lot more to make it work better on Graal. But we're also very much focused on regular Java because that's what most people are going to be using in the short term. But Micronaut provides you that pathway forward to Graal. And the cool thing about Micronaut is, like, if you build a library or an application for using Micronaut, and then one day you want to get it running on Graal, the steps that you have to take to get there are much shorter because it's already prepared with that in mind. Because Graal is not something you can just decide to add afterwards. You have to plan ahead. You have to think about it from the beginning. It's not something you can just say, I'm going to write a Java app and then in 2 years I'm going to put it on Graal. That doesn't work like that. You have to really plan ahead and plan that you're going to use it. And Micronaut will make that a lot easier. So in terms of Java's problems for frameworks, These are essentially a list of problems that I personally have had to deal with in the last over 10 years of developing frameworks for Java. So one of the things one of the benefits of having built a framework like Grails is that you become so familiar with these set of problems that they become kind of second nature, and you fight with them. And you guys, maybe consumers of a framework don't often maybe see this, but the developers of a framework see these problems all the time, and it's immensely frustrating. And when we started Micronaut, I was like, I want to eliminate all of these problems. If we build a new framework and we're going to make it amazing, it's going to have to solve all of these problems. So some of the problems that for Java frameworks in general in Java is there's a very limited annotation API. So Java has annotations, but there's no way to really query what annotation is annotated by another annotation, like meta annotations where you have an annotation on another annotation. Or there's no way to merge annotations from different sources. So if you have a class that has one annotation and it extends from another class that has another annotation that implements another interface that has another annotation, and you want to get all those annotations into one kind of merged form, you have to do that manually. It's a very limited API. The annotations are there, but how you get them and how you query them it relies on reflection. So that presents a massive problem. Another massive problem for frameworks is type erasure. Type erasure is a massive problem for languages and all sorts of reasons, but type erasure is really painful for a framework developer, because I've declared this property or this field or this method to return a list, angle bracket string. A list that takes a list of strings, right? That should be so easy to just, I want to know that return type is a list of string. That should be easy, right? It should be so basic. But the Java, because at compilation time the type is erased, that method or field no longer has that reference. And there's this weird API in Java where you have to get generic parameterized types, and you have to compute, and it's different the way you get it depending on whether it's a field or it's a class. Just working out generic type arguments in Java is the most painful thing that can ever have been imagined when you have to do it at runtime. And you have to cache it. So because you have to cache all these things, you have to consume memory. And the same problem with reflection. Reflection is slow in generally, but then also it consumes memory. And the problem is that everybody creates a different cache. I don't know if you've noticed this, but reflective data caches are everywhere, because there's no generic API in Java to cache reflection data. So Jackson has its own reflective data cache for JSON to get hold of all the methods and fields and properties that it's trying to serialize to JSON. Then Groovy has its own cache because it's trying to get all the meta classes and so forth. Then Spring has another reflective metadata cache. Then Hibernate has another metadata. You have all these reflective caches for the same data because there's no way to universally cache reflective metadata, so everybody caches it. Every single tool or framework or whatever that you use ends up caching it. So if you can eliminate those caches, you save mega amounts of memory, just mega. Class path scanning as well. Things like Spring and Jakarta and so forth have very complex bytecode analysis to scan your class path at runtime, and there's just no way to get class path scanning to perform well. It involves a heck of a lot of I/O. You have to read the class files at runtime. You have to parse the class files. It's horrible. Class path scanning is a horrible thing, and Micronaut does not do it. Dynamic class loading as well is slow compared to static class loading, of course. So relatively. So we've eliminated dynamic class loading. So all of this means that a Micronaut app will start up. When you create a new app, you'll typically start up in around under a second, and will consume a heck of a lot less memory. So in Micronaut 1.1, we've improved a lot about Micronaut as well, making it even more refined in terms of dealing with more cases of where reflection is required. So we've introduced a new bean introspection API, which is essentially a replacement for java.beans.introspector. Java.beans introspector is culprit number one for memory consumption in frameworks. It has its own separate reflection cache. Oh yeah, there's another reflection cache in java.beans.introspector, another reflection cache. So that one, we wanted to get rid of it because a lot of things use that. And the bean introspection API, what it does is it lets you like read a bean and set and get properties on the bean, look at its generic type arguments, inspect its annotations, and so forth, without using reflection at any point. So that's an important improvement for Micronaut 1.1. And an example of using that is we have in Micronaut 1.1 we have a Jackson module that allows you to serialize and deserialize JSON objects to JSON without using reflection. Yeah, and without using reflection and without using CGlib or ByteBuddy or dynamic, because Jackson has an afterburner module that uses runtime bytecode generation. But again, that's going to suck memory-wise. So that's an example of using that. We've also completely eliminated framework-level dynamic class loading. In Micronaut 1.0, there were a few areas where we were still doing dynamic class loading, and now we've eliminated those. We've modularized Micronaut, so it's a lot more modular with different sub-projects. We started off with one like massive repo with all the different projects as kind of sub-projects, and now we have Micronaut Kafka, Micronaut gRPC, Micronaut, etc. We've implemented testing improvements, so Micronaut Test is an extension that can be used with JUnit 5 and or Spock, and you can annotate either a Spock test or a JUnit 5 test and execute it, and it's really simple to use, bootstraps Micronaut really fast, and allows DI into the test itself. In terms of the new modules for Micronaut 1.1 that we've introduced, these are some areas that many folks will be interested in. We have a mistake on the RabbitMQ one. Anyway, that's meant to be RabbitMQ there. So gRPC, we have the gRPC module that lets you build gRPC applications with Micronaut. We have GraphQL, a GraphQL module, a RabbitMQ module, an AWS module which we've separated out and added support for things like Alexa skill development, things for like AWS API proxy and so forth. And we also have support for Google Cloud project, which allows integration with things like Stackdriver, Trace, and so forth. So now I'm going to do enough talk, and I'm going to do a little demo of the new Bean Introspection API, which is one of the things, maybe like as you guys maybe are not so excited about this because this is maybe like more low level, but I'm like so excited about this API because because it's going to allow us to do like so many things, especially when we're starting work, and I'll talk about it later on, like the improvements to data access and validation and all sorts of things. But the Bean Introspection API in Micronaut 1.1 is ridiculously cool because it's going to allow us to do a lot more framework level things, and allow you guys to do framework level things as well.
Can I ask a question before you move on, please?
Yeah.
So all of the benefits that you were just talking about with reflective data caches and all of that,
Mm-hmm.
do you lose any of that when using Groovy with Micronaut?
So I think that Groovy is going to have a reflective metacache because that's the way the language works, and it's necessary for the functioning of the language. But if we can eliminate from the frameworks the reflective meta, then it means like Groovy's overall memory consumption is a lot better, right? because the problem is the proliferation of reflective metadata caches. When you have one reflective cache for Jackson, another reflective cache for Hibernate validator, another reflective cache for Hibernate, another reflective cache for Spring, another reflective cache. It's just there's reflective caches everywhere, and getting rid of them all is Micronaut's mission in life, one of its missions anyway. So we're trying to reduce memory consumption, and the way you do that is through elimination of reflection, and or at least reducing the use of reflection to the absolute minimal. Yeah. Otherwise, you can't achieve it. So yeah, what the Bean introspection API, the way it works is you can add introspector to any POJO, and at compilation time we compute the Bean introspection, and so that you can introspect and instantiate and set and get properties on a Bean and so forth. Now we also you can also write annotation mappers that which is a completely different subject. But for example, when you do in a Micronaut 1.1 app, when you have an at entity, like a JPA entity, it automatically becomes introspected as well. So if you want to like make existing annotations introspected, that's possible with Micronaut. But what happens is it'll compute an introspection. So what is an introspection? Because so what you can do is, instead of doing introspector in Java, I think it's this guy, get bean info on that class, which would create a reflection-based implementation. You say bean introspection, get introspection, book.class, and with this introspection, that'll give you an introspection, right? And with this introspection, what you can do is instantiate a new book, like so. And we'll just say assert not null. And what that does is, basically I can now, without reflection, I can instantiate my book instance, and without having to do class.new instance, try catch, etc. And it's not using reflection at all. It's directly instantiating that instance, which obviously from a memory consumption perspective is a lot better. From a Graal VM perspective, it's a lot better because the native image for Graal will know how to deal with that without having to having special reflection stuff. And critically, what we can do is there's another API related to this, called Bean Wrapper, which you can wrap around an existing bean. That'll give me a wrapper, and what you can just say is like set property title, the stand, like so, and you see it has a title property. And then we can say assert equals stand wrapper get property. So, and that will essentially, I think I'm going to use get required property title. If we execute that, it should pass, and it does. So what I'm doing here is I'm setting and getting properties on the actual bean instance, and I'm doing that without at any point using any kind of reflection. So I can get a wrap around the instance. I can set and read and write data on the property. So you can imagine this being used. This is a prerequisite that we needed in Micronaut in place. Kind of one of the building blocks we needed in Micronaut before you think about, hey, I want to read a database record from somewhere, and then I want to instantiate a book, and then I want to set the properties on the book from the database, and you want to do that without reflection, yeah? So in order to write any kind of relational data integration or database integration, this is what you need. You need something like this, and if you want to do it without reflection, and you want to do it pre-computed, this is how you do it. So the other cool thing that it does is it creates like indexes. So like in a lot of Java projects, a lot of Java specs, like for example, bean validation. The bean validation spec says that you are allowed to define annotations like not blank and size that define like validation constraints on either the field or the method. Yeah. So I've got one here on the method and one here on the field. Now this is immensely problematic from a framework developer's perspective, because to compute that at runtime, the cost is immense, because you have to at runtime reflectively get the method, check the size, check the constraints on the method. Then you have to convert to the property name equivalent, so you have to get rid of the get part and then convert it to lowercase, get the title. Then you have to search for the field reflectively. The field is not accessible because it's private, so you have to set accessible on the object breaking all encapsulation rules. Then they all follow the module system and everything that. Retrieve the field, figure out the annotations on the field. Does it have not blank? Yes, it does. Okay, now we have computed the constraints at runtime. Yeah, and as your object gets bigger, with more properties, more inheritance, more whatever, suddenly you have this massive algorithm to compute constraint validation, right? That is painful to compute at runtime and consumes immense amount of memory. And the only way you can get it to perform well is by caching, more reflective caches. So we don't cache. Instead, Micronaut computes at a compilation time. And what you can do is things like I can say on my introspection over here, I can say introspection get indexed properties constraint. Sorry, get indexed properties, because we index by default, and the annotations that you index are customizable. So we actually create indexes for constraints by default. And that will return me all the properties that basically have a constraint on them. Yeah. So I can search my bean introspection, which is computed ahead of time at computation time, for all the properties on my bean that has constraint validations on them. And once I have those properties, I can get hold from that property. I can say get annotation metadata to get my annotation metadata, which is computed ahead of time on that property. And I can say annotation metadata get annotation types. I think it is types by stereotype constraint. And that's going to give me all of the annotations on that object that has the constraint stereotype. Then I can iterate over that, and I can get the actual annotation value for that stereotype. And all of that is from pre-computed data that already exists and is computed at compilation time. And the actual annotation value, I'm just going to output the annotation.name, and we're going to see how this works. So you can see that I've computed two annotations, size and blank. And you see that the size in the blank field, one was declared on the field, one was declared on the method, but the introspection already computed that at compilation time. So there's no work involved. Yeah? So I can write things like bean validation and data integration and all sorts of things using pre-computed data, which is everything that Micronaut is trying to achieve. Okay, I realize that the talks here are 45 minutes, so I'm going to have to get a move on. So introspected allows you to do ahead of time reflection-free, it's an ahead of time reflection-free replacement for introspector, get properties, create instances, and it computes the annotation metadata at compilation time, meaning that we can implement things like database access, like validation, like all sorts of things in future versions of Micronaut without using a reflection. It's a critical feature of Micronaut 1.1 and the one I'm most excited about. Annotation metadata is like the pre-computed annotation data for any, like with all merged from all your interfaces and superclasses. It computes it at compilation time. You can check whether a particular stereotype annotation is present, and it includes knowledge of meta annotation. So you can see in my example that I showed there, I was getting from the object all of the annotations that are annotated with the meta annotation constraint. Yeah? So size and not blank are annotated with constraint, and I queried get me all the constraints, and it worked it out. Yeah? So it computes annotation metadata. We can also do things like Micronaut will also compute the generic type arguments ahead of time. So you can say, just get me the first type argument to the list, and it's already there. There's no type erasure. There's no crazy reflection logic to get the type argument. It just works. Generic type and type erasure problems are a thing of the past. Micronaut's dependency injection layer pre-computes everything as well, all annotation data, all generic types. It doesn't use any class loading. We have this notion of a bean definition. So every time you define a bean, you can get hold of it, the definition that contains all of your pre-computed annotation metadata info, and is used by the application context to instantiate beans. A bean definition is produced for any object annotated with scope or singleton. We encourage constructor injection by default. So historically, DI systems that use a reflection haven't encouraged constructor injection because it's more complex to implement. But that's not an excuse. It should be the simplest way because it's the best way. Constructor injection is what we encourage by default. We are compliant with the Java inject spec and TCK. So javax.inject is a specification, has a TCK, and we have the TCK running and it passes. You can define configuration properties. So I can say at configuration properties some string and then pass configuration to my object, and it will bind to that object. And the binding is done at compilation time and reflection free. The binding is done at runtime, but the actual setting of the properties is reflection free and without compilation. Without reflection, sorry. In the DI part, you can define custom requirements to make completely dynamic systems. So even though that Micronaut doesn't use all those crazy reflective features and all those dynamic things, you can still be completely dynamic. It's just we compute it ahead of time. So you can do requirements. You can say this bean requires that example.enable the set. It requires the presence of a data source, and it requires that no other example bean is present, otherwise it won't load. So you can define custom requirements for any bean. Executable as well is one of my favorite other features of the framework. Executable is like a stereotype annotation that you put on other annotations. So for example, @scheduled is annotated with @executable. And what it does is it identifies the points in the framework where we invoke your code so that we only compute reflection-free handles to your code, which are called executable methods for those points in your code. That's how scheduled works. So we have a scheduled method processor that processes every method in the system that's annotated with @scheduled, and it receives the executable method, which it can invoke without using reflection, and compute it ahead of time. I'm probably not going to have time to do this, so we're just going to run. Around advice is AOP advice in Micronaut is amazing. It's so simple. It's so easy. It's computed at compilation time. It's so liberating never having to write another proxy factory bean. Seriously, if I have to write another proxy factory bean, you never have to write a proxy factory bean in Micronaut. They don't exist. Everything is computed at compilation time. You simply define another annotation which is annotated with a round, and you point to the type that implements the annotation. You put it on your method, and the interceptor is invoked. Nothing else needs to be done. No proxy creation, no cglib, no byte buddy, nothing. It just works. Introduction advice is equally simple. Introduction advice is what powers like the HTTP client. So you can say add client on an interface, and it gets implemented for you at compilation time. Again, it's absolutely simple how it's done. You just define another annotation that's annotated with introduction, that has a type that implements it, and it calls that advice at runtime, and you can implement the introduction without using any kind of proxies or anything. So what's on the Micronaut 1.2 roadmap? Because we're about to release Micronaut 1.1. We're at RC2 phase for Micronaut 1.1 now, and it's going to go GA in the next couple of weeks. So for Micronaut 1.2, the focus is this. We have in progress support for OAuth 2 and OpenID Connect. It's currently we're publishing snapshots and we're getting feedback. We're going to do a GA release of the OAuth 2 and OpenID Connect support. We are saying goodbye to Hibernate Validator. Reflection-free bean validation is coming in Micronaut 1.2, so you'll be able to validate and completely your data and without pulling in a 3 megabyte jar file that is a big ball of reflective mud. We are starting the data access project, which is codenamed Graeme for Java, which will essentially provide the same developer productivity that Graeme does, but for Java and Kotlin, and implement the data access repository part at compilation time. And we're going to have support for Kotlin coroutines, and JMS support is on the horizon as well. JMS support might not make it into 1.2, but it's good to have a bit list of ambitions, and this is the kind of future roadmap stuff. In summary then, Micronaut provides an absolutely awesome foundation, and it is the foundation that we're going to be building pretty much everything on, including Grails 4. So I have a Grails 4 talk in the afternoon where I'll be talking about Grails 4 and how we're rebasing a lot of it on top of Micronaut. What sacrifices compilation speed, so Micronaut has more overhead compared to other frameworks at compilation time, although it's fairly minimal, but you gain so much more. It solves so many problems for framework level problems, and those framework level problems, you think they're framework level problems, but they become your problems, yeah, when you use the framework. So this Micronaut solves so much with existing solutions like Spring and Jakarta and so forth, and Java in general. And that's the reason why it's creating such a revolution in terms of changing the way server-side Java is done. I can guarantee you that in a few years' time, every single Java framework in the Java landscape that is popular will be using a similar approach to Micronaut. I can guarantee you. The Spring team are undoubtedly working on something. Red Hat are working on Quarkus. Micronaut is paving the way and pioneering a way forward in how to build efficient applications on Java. And it also opens the door to GraalVM native, and like I said, GraalVM is still very much experimental, but it's Micronaut. I think Micronaut and GraalVM are probably the two most exciting technologies in server-side Java right now. So yeah, that is my talk. Now we have time for questions. Yep.
So I was talking to a coworker a week or two ago, and the topic of Groovy and Grails came up.
Mm-hmm.
And I've been, as you know, I've been a Grails and Groovy user for a long time and continue to be a big user. But his opinion was that Micronaut itself was proof that OCI and the Groovy community in general was kind of going away, and OCI has no commitment to Groovy or Grails because of Micronaut, and they're focusing completely on Java. And I just wanted to kind of get your response on that.
That is completely false and an incorrect impression. We are 100% committed to Grails. We just released Grails 4 Milestone 2 on Tuesday. It's true that our focus is on Micronaut and bringing Micronaut features to the Grails community. I think what we want to do is what we want to build is in everything we innovate on. We want to benefit the Grails community. We want it to benefit the Java community. And we want it to benefit the Kotlin community, and we want it to benefit everybody. So our focus is on changing the foundation that we build stuff on, and that's why in Grails 4, Micronaut is essentially integrated into Grails 4. And every Micronaut feature, whether it be the HTTP client or the Kafka client, is usable from Grails. And we're really excited about Grails 4. A few days ago, we did a Grails 4 webinar at OCI, and we were blown away because we had like I don't know how many hundred, it was 600 people attending the webinar. There is a huge amount of excitement for Grails 4. We're really excited about Grails 4, and I'm looking forward to talking about Grails 4 in the afternoon. Any other questions?
One question regarding the...
Yes. I did have the question. And then
regarding the Bean Introspection API, will it be available for any other framework or library to be used outside of Micronaut?
Absolutely.
So
the Bean Introspection API only requires the annotation processor and the Micronaut core runtime library. Micronaut core it doesn't have any other dependencies, so it's very slim. It can absolutely be used. Micronaut is really modular, and whether you just use the Bean introspection part or just use, for example, I've seen one person that just use, because we have support for Spring annotations in Micronaut for Spring. Somebody I saw was using Micronaut for Spring and the Micronaut annotation processes to generate Swagger for his Spring project, just at compilation time. Right? So it's very modular. You can do what you want with it. Anyway, before I forget, I have...
1,986.
How many?
1,986.
So Micronaut currently has 1,986 stars. Who in here has not starred the repository? Huh? No, don't be shy. I'm not being critical. Okay, so this may be problematic then if there's not that many people. But anyway, I have a Micronaut app here that is a CLI application. Yeah, that basically when I run it, it tells me how many stars. It's a Micronaut app that's a CLI app, and when I run it, it tells me how many stars Micronaut has and who was the most recent person to star it. So I thought it could be fun, but this may not work out if everybody started. Why have you all started? But basically, the idea was the person to get to 2,000 stars, I hope is at this conference, will receive a Micronaut T-shirt. So, get starring, and we'll see how. Who ends up being, and then later in the day, I don't know, in my next talk, we will ask the GitHub user ID who that person is, and they will receive a Micronaut T-shirt for being the 2,000th person to start the repository. So yeah.
Deal. So we don't have time for more. Let's go for coffee downstairs.
Let's go for coffee, and then my next talk.
In the Graeme's talk, which is the last one in the day.
Yeah.
Graeme's talk.
So we'll be keeping an eye, and I'll be running my little script. Which is with my Micronaut app, which is reading the stars, and yeah, we'll be giving it away. Okay, so any other questions? Then no, we go for coffee.
Any other questions?
Any other questions? No. Okay, well, thank you very much. If you have any questions, I'll be downstairs.